In April 2018, investigators announced they had caught the Golden State Killer through DNA. That is the story most people know. What they do not know is that for decades, these crimes were not even connected. 13 murders, more than 50 sexual assaults, spread across California under different names, chased by detectives who never realized they were hunting the same man. Before DNA could crack anything, someone had to find a pattern hidden inside years of seemingly unrelated violence. What they uncovered began not in a lab, but inside the crime scenes themselves. In the mid-1970s, homes across Northern California began to experience a series of highly specific residential break-ins. The intruder did not just steal, he systematically bound his victims using a precise method, often utilizing cords or shoelace restraints found on the property. In cases involving couples, he placed kitchen plates on the back of the bound male, threatening to execute everyone in the house if he heard the dishes rattle. This plate-stacking ritual, combined with subsequent taunting phone calls to survivors months after the attacks, formed a distinct behavioral signature. Witness descriptions varied wildly, sketching a shifting gallery of heights, weights, and hair colors, making physical descriptions notoriously unreliable. Instead, it was the offender's highly repetitive, rigid method of operation that became the primary means of linking the crimes. The way he controlled the environments, moved through neighborhoods, and manipulated his victims carried far more weight than any single witness account. In 1994, Paul Holes joined the Contra Costa County Sheriff's Office. Tasked with reviewing cold files, Holes spent his spare hours examining decades of scattered records from different jurisdictions. He began organizing the chaotic files into a unified timeline, focusing on these recurring physical signatures rather than eyewitness testimony. By cataloging the exact binding techniques, the auditory intimidation, and the specific staging at each scene, Holes worked to prove that these geographically isolated attacks were not the work of copycats, but the deliberate, evolving path of a single serial predator. The offender's theater of operation eventually expanded far beyond the suburban tracts of Contra Costa and Sacramento counties. Between 1974 and 1986, the geographical footprint of the crimes grew to span 10 California counties. In the late 1970s, the perpetrator had established a highly localized reign of terror in Northern California as the East Area Rapist. Then, the trail in the north abruptly went cold. Hundreds of miles away, in the coastal communities of Southern California, a new series of late-night residential attacks began. In Ventura, Orange, and Santa Barbara counties, couples were targeted inside their homes, bound, and executed. Operating under the name the original Night Stalker, this southern predator seemed to local authorities to be an entirely separate threat. The sheer physical distance between these jurisdictions, combined with the escalation from sexual assault to homicide, kept the investigations completely isolated. However, when investigators plotted the locations of all these offenses on a single map of California, the geographic spread emerged as key evidence. The offender consistently chose single-family homes in newly developed suburbs, specifically those backing onto public easements like canals, creek beds, or school athletic fields. These greenbelts provided hidden approach and escape routes, a tactical preference that repeated across hundreds of miles. This spatial pattern reframed the entire investigation. Rather than tracking a series of localized criminals, analysts realized they were looking at a highly mobile offender who possessed intimate knowledge of the state's geography. The vast distance between Northern and Southern California was no longer a barrier to linkage. Instead, it was the logical logistical footprint of a single individual utilizing the state's highway corridors. The case shifted from a desperate search for local suspects to the reconstruction of a highly calculated, statewide path. The physical scenes of the attacks contained a quiet trail of biological evidence, though its true value remained locked for decades. Investigators preserved semen from early medical examinations, They bagged the ligatures, the cords, ropes, and shoelaces used to restrain victims, knowing these fibers held microscopic epithelial skin cells shed during the forceful tying of knots. On window frames and door latches, technicians swept for touch DNA, targeting the invisible skin flakes left behind when fingers pried open home entry points. But having recoverable biological material was not the same as having an identity. During the peak of the attacks in the 1970s and the 1980s, forensic DNA analysis did not exist. By the time the technology developed, investigators faced severe physical limits with the preserved evidence. Many samples had degraded inside cardboard boxes stored in property rooms that were not temperature controlled for 30 years. Exposure to warmth, humidity, and simple decay had broken down the genetic structures, leaving fragile, fragmented sequences that standard testing struggled to process. Other samples were low-level, containing only a handful of usable cells. At this microscopic scale, the threat of contamination from crime scene responders or laboratory handlers was extremely high, risking the loss of the only physical link to the offender. Even a pristine sample had clear limits. It could link different crimes to one perpetrator, but without a matching name in a file, the code remained entirely anonymous. The Federal Bureau of Investigation launched the Combined DNA Index System, known as CODIS, in 1990. This national network was designed to find perpetrators by comparing crime scene DNA against profiles of convicted offenders. The technology relied on short tandem repeat, or STR, analysis, which compares specific genetic markers to find a direct match. For cold case investigators, this database represented the ultimate hope. They possessed a clean genetic profile of the killer, extracted from preserved crime scene evidence, and they uploaded it into the national system. The system searched through millions of offender profiles. Month after month, year after year, the database returned no matches. CODIS only works if the perpetrator has already been arrested and typed for a qualifying offense. Because the killer had not been convicted of a crime that required a DNA sample under California law during the database's expansion, his genetic sequence did not exist in the system. This was a scientific wall. Police agencies across the state had dedicated thousands of hours to chasing leads, interviewing suspects, and preserving physical evidence. The lack of progress was not due to a shortage of effort or resources. Technicians had extracted viable DNA, and detectives had verified that the same individual committed murders in both Northern and Southern California. Yet, the forensic tools of the era could only match a suspect who was already known to the law. Without an existing profile in the criminal database, the genetic sequence remained a lock without a key. To break the stalemate, investigators had to find a completely different method to translate the genetic code into a name. The National Criminal DNA Database, CODIS, relies on short tandem repeat, or STR, analysis. This method examines around 20 specific regions of DNA, looking for a direct, identical match between a suspect and a crime scene profile. If the offender's exact profile is not already in the system, the search yields nothing. To bypass this scientific dead end, investigators turn to single nucleotide polymorphism genotyping, commonly known as SNP analysis. Unlike STR typing, which looks at a small handful of locations to verify a direct identity, a high-density SNP microarray reads hundreds of thousands of individual genetic markers across the entire genome. This process creates a massive, detailed genetic blueprint, the exact same format of raw data used by commercial consumer ancestry services. This shift in technology fundamentally altered the logic of the search. Instead of looking for a perfect one-to-one match to identify the killer directly, investigators uploaded this detailed SNP profile to GEDmatch, a public, crowdsourced database where users voluntarily share their genetic information. The objective was no longer finding the perpetrator himself, but locating his family members. GED Match's software calculates the amount of shared DNA between the uploaded crime scene profile and millions of other profiles in the system. When two people share a common ancestor, they retain matching blocks of genetic material. By finding distant relatives, such as third cousins who share less than 1% of their genome, investigators could work backward. Rather than waiting for a direct hit that might never come, forensic analysts could now map the vast, interconnected branches of extended family trees, tracing the lineages of completely unsuspected citizens to find the point where their lines converged. The task of untangling these distant genetic connections fell to Barbara Ray Venter, a retired patent attorney who had pioneered investigative genetic genealogy. Working with the handful of third cousin matches from the public database, individuals who shared less than 1% of their DNA with the crime scene profile, Venter began the detailed process of reverse engineering a massive family network. She mapped the shared genetic segments backward, searching for the common ancestors where these separate family lines merged. Once Venter identified those ancestral nodes, she built the branches forward toward the present day. This required combining genetic data with traditional paper trail research. She analyzed federal census records, birth indexes, marriage certificates, and local obituaries, tracing every descendant's path to see where they lived and worked. The goal was to eliminate branches that could not fit the physical reality of the crimes. Venter pruned the tree by applying basic parameters. She looked for males born in the 1940s who had a documented presence in California during the active years of the attacks. This systematic process gradually narrowed a sprawling web of thousands of relatives down to a small, highly specific candidate pool. This genetic mapping did not provide immediate forensic proof. Under legal standards, a family tree constructed from public databases is not admissible evidence to secure a conviction. Instead, this hybrid methodology functioned purely as a lead generation tool. It did not identify the perpetrator directly, but it gave investigators a physical map, pointing them toward a localized group of individuals who shared a specific lineage. For the first time in 40 years, detectives had a concrete starting point to investigate. The genealogical search pointed to Joseph James DeAngelo, a 72-year-old former police officer living in Citrus Heights, California. An entry on a family tree was not enough to make an arrest. Under California law, genealogical leads from public databases serve only as investigative tips. To file charges, investigators needed direct, physical proof that could withstand the strict standards of a criminal court. Detectives placed DeAngelo under surveillance, waiting for an opportunity to collect a fresh biological sample. When DeAngelo discarded a coffee cup and a used trash bag outside his residence, surveillance teams immediately seized the items. Because these materials were left in public waste, they were legally classified as abandoned property, allowing police to collect them without a warrant. The recovered items went directly to the crime laboratory under strict chain of custody protocols. Technicians extracted DNA from the discarded items and conducted a direct comparison against the 1980 Ventura County crime scene sample. The analysis compared the profiles using traditional short tandem repeat testing, bypassing the statistical probabilities of genealogy. The laboratory returned an exact match. The genetic profile from the discarded trash matched the DNA left at the crime scene decades earlier. This direct, physical comparison transformed a genealogical theory into a verified identity, providing the exact scientific confirmation needed to secure an arrest warrant. Decades of careful evidence preservation by crime scene technicians had met the precise standards of modern science. On April 24, 2018, police arrested DeAngelo outside his home. The handcuffs and court hearings bring a legal end to a 40-year search, but they do not return what was taken. For the survivors and the families of the deceased, the damage remains permanently woven into their lives. For decades, these individuals carried the weight of unanswered questions, waking to the realization that the intruder who violated their homes and took their loved ones was still free. Children grew up in homes shadowed by their parents' unspoken trauma, and families learned to live with a quiet, persistent vigilance. While the DNA match provided a name, it could not undo the decades spent looking over shoulders, locking doors twice, or wondering if a passing stranger was the predator from their past. When justice arrives this late, it is inherently incomplete. Many parents, spouses, and detectives died before ever hearing the name Joseph DeAngelo. For those who survived to see him sit in a courtroom, the conviction offers a resolution, but not a cure. The emotional toll of these crimes persists, serving as a reminder that behind every genetic breakthrough and forensic milestone are human lives permanently altered. The use of public databases to unmask a killer shifted the conversation from criminal investigation to public policy. When Joseph DeAngelo was identified, millions of users of consumer genealogy sites realized their genetic profiles could be used by law enforcement. Most of these individuals had uploaded their raw DNA to find distant ancestors, not to assist in police investigations. Under this model, a single person's decision to share their data effectively compromised the privacy of their entire extended family without their knowledge or consent. This created an immediate conflict between public safety and genetic expectation. In response, platforms like GEDmatch changed their rules, shifting from automatic law enforcement access to an opt-in model where users must explicitly permit police searches. While some argue that solving violent crimes justifies these matches, others contend that genetic data deserves strict constitutional protections. Because DNA is shared across generations, one relative's curiosity can expose the biological details of family members who never purchased a testing kit. The debate remains unresolved, balancing the collective interest in solving cold cases against the individual expectation of genetic anonymity. Today, the technology that unmasked a monster is rewriting the rules of privacy. With every genetic upload, the line between personal anonymity and public security blurs. Our own biology has become the ultimate investigator, ensuring no cold case is safely hidden in the past. But as this digital dragnet expands, we must ask what we are willing to surrender for justice. Subscribe for more deep dives.